Welcome to the next part of the module on Android services and security, which begins our analysis of how to program a started service. In this part, we'll analyze key elements of the design of a download application and show by example how a started service can concurrently retrieve and display an image from a remote server. Before delving into the details of the solution, however, we'll first outline the overall structure and functionality of the download application. This application contains a download activity. When a user presses the Download Image button, this activity launches a download service on demand by creating an intent command and passing it to the Start Service method. After the download service is launched by Android, it uses a URL passed with the intent to concurrently retrieve the image and store it in a file on the device. If all goes well, the download service returns the path name of the file containing the image back to the download activity, which then displays the image to the user. We'll just cover steps 1 and 2 in this video. Later videos show how to return the path name from the service back to the activity using various Android inter-process communication mechanisms. The source code for the download application is available at this link, so download it and watch this video and the next one carefully, perhaps multiple times, to learn how it works. This is the most complicated example covered thus far in this MOOC, since there are 4 main components involved in the solution, as well as various Android service, concurrency, and communication mechanisms. So we'll progressively analyze the design and implementation from various perspectives to show how all the pieces fit together. We'll now summarize the steps involved in programming started services, using our download application as a running example to reify each step. In general, a client, typically an activity, launches a started service by calling the Start Service method, as discussed here. For example, the download activity uses a factory method to create an intent command that identifies the service to start, which in this case is the download service, and supplies a URL parameter via intent data that tells the service what image to retrieve from a remote server. The Start Service method requests Android's Activity Manager service to start the service asynchronously, so this call doesn't block the client synchronously while the download service runs. In response to the Start Service call, Android's Activity Manager service will launch the service if it's not already running, using the activator pattern described here. The Activity Manager service then invokes the service's onCreate and onStart command hook methods to initialize the service. It inherits these methods from the service superclass. The download service's onCreate hook method starts a handler thread, which is used in conjunction with a service handler object to download the requested image in the background, store it in a file, and return the path name of the file to the client. The onStart command hook method is called each time a started service is sent an intent via a call to the Start Service method. The download service implements onStart command to send the intent to the background handler thread for concurrent processing. OnStart command returns a value to the Android service framework, but this value is not propagated back to the client that invoked the Start Service method originally. Instead, this return value tells Android what it should do with the service if its process is killed while the service is running. The valid return values are Start Sticky, which tells Android not to redeliver the intent to onStart command when the service is restarted. Likewise, the Start Not Sticky return value tells Android the service should remain stopped unless it's explicitly started by some client code. And finally, the Start Redeliver Intent value tells Android to restart the service via onStart command, supplying the same intent as was delivered to it this time. More information on these return values is documented here. A started service typically performs a single operation and doesn't need to return a reply to the client that started it. In our download application example, the download service defines a download image and reply method that runs in the background handler thread. This method extracts the URL from the intent, uses it to retrieve the image from a remote server, stores the image in a file on the device, and then returns the path name to the image to the download activity client, which subsequently displays the image. When an operation is done, the service can be stopped. For example, the download service calls stop self to shut itself down when it's done retrieving and processing an image. A service that stops itself must be careful that there aren't concurrent operations processing other intents, as we'll discuss later in this video. A service can also be shut down by another component. For example, the download activity could call the stop service method to unilaterally terminate the download service. Now that we've summarized the steps involved in programming started services in general, and the download service in particular, we'll examine the design of the download application, which contains a download activity and a download service. As outlined earlier, when the user presses the download image button on the screen, the download activity sends an intent with a URL to retrieve via a call to start service, which launches the download service on demand using the activator pattern. The download service performs four main actions. First, its onCreateHook method creates a service handler, which extends the Android handler class. The service handler is associated with a single handler thread that runs in the background with its own thread-specific looper and can be used to send and handle messages, as discussed in the earlier video on the Hammer framework. Second, the download service itself receives an intent from the download activity via onStart command and calls the service handler's sendMessage method to insert the intent into the handler thread's message queue for subsequent processing. Third, the looper in the background handler thread dispatches the service handler's handleMessageHook method, which downloads the image designated by the URL in the intent and stores it in a file. An upcoming video will show how the Android Messenger interprocess communication mechanism is used to pass the path name of the file back from the download service to the download activity. Finally, the download service stops itself when there are no more intents to handle. This design is guided by the command processor pattern, which packages a piece of application functionality and parameterizes it in an object so it can be executed in a different thread or process, as described here. The download service applies this pattern to offload tasks from an application's main thread to a single background thread, which works well if a service needn't handle multiple requests concurrently. In summary, this part of the module progressively analyzed the structure and functionality of a download application to show by example how to program a started service that concurrently retrieves and displays an image from a remote server. A started service is launched on demand by another Android component, typically an activity, and its lifecycle is independent of the component that launched it. A started service can therefore run in the background indefinitely, even if the component that launched it is destroyed. Started services are driven by inversion of control from Android's Activity Manager service, which dispatches service lifecycle hook methods such as onCreate, onStart command, and onDestroy in response to various events generated by applications and the Android infrastructure. The next part of this video shows how these hook methods can be implemented by applying a common Android idiom for concurrent service processing, which is based on the command processor pattern discussed later in this MOOC.